The M&M decay, or the radioactive decay lab, tends to be some of my students' favorite because it involves candy. What you're going to do is use candy or pennies or Skittles, M&Ms, whatever you happen to have access to. It has to be something with two sides. One that has like a heads or tails or has an M or no M, just something that you can be able to easily see whether or not a reaction, a decay has occurred. On this one, there's a little bit of math that goes along with it. I'm going to try to walk you through those parts in the next couple of slides, but enjoy this one. You'll get some practice graphing, get some practice reading graphs, and then also you'll get to enjoy the candy at the end. So good luck. Okay, so this is a fun lab. We are going to look at radioisotopes and radioactive decay using a brand new element. This element is called M&M. Here I have a picture of M&M right there. Isn't that cool? So if you notice, M&M is shown by having an M, or if you're really blonde, a 3 or an E or a W, whatever the case might be. So if it's showing that white M, that means that it's M&M and it's radioactive and it is not safe to eat. So take this back. What you're going to do is you're going to get a bunch of M&Ms or Skittles or pennies, and you're going to put them in a cup. You're going to shake it and you're going to roll them out. There we go. Hopefully we can see that. Now, if you see the M, that means that it's still an M&M and it is not safe. So this has the M, this has the M, this has the M. Now this one, the M is gone. That means this one is safe to eat. That one's safe. This one's safe. There's an M, there's an M. And so you're going to divide them into two groups. Now it should be about half will decay every single time. Now in the lab, for every one that you take out, you're supposed to replace it with a nerd. If you don't have nerds, don't worry about it. All I'm trying to show is that the number of nerds will go up every single roll. Now the ones that are still M's, you're going to pick those up, you're going to put them back into the cup, and you're going to roll again. The ones that no longer have M's, that have decayed to something safe, you can enjoy those. You will keep repeating this until all of the M's have decayed. Now, as you're doing your rolls, you'll want to fill out this table. This first box looks at the total number of M&Ms that you have. Now, after your first roll, you're going to say this is how many M's are showing. This are how many M's aren't showing that are safe. Now you're going to keep doing that and filling out those two tables, or those two columns, excuse me. The total number of nerds, that's going to be the number of M not showing, so this column right here, plus the column above. So the total number of nerds keeps going up. So let's just say we started with 101. I had 51 that had the M showing. I had 50 that were not showing. I would add 50 nerds. Now I'm going to take those 51 M showing and I'm going to roll them again. This time maybe I get 27 where the M still shows, and I end up with, oh, I hope my math is okay, 24, I think that's right, 24 that aren't showing. Now my total number of nerds is going to be the 50 plus the 24. It's going to give me 74 nerds. And you're going to keep going until finally it gets to 0. The percent M showing, you're going to take the number of M in that row divided by the total. So it's the number of M divided by your total times 100. So that number up on top, in my case 101, will be used every single time. The ratio of decayed to undecayed, you're going to take the number of nerds to the number of M showing. So for this first one, it's 50 to 51, and you can reduce that down. It's about a 1-to-1, which is what we would expect. The second one, well, let's see here, that's a 74 to 27. Let me grab my calculator really quick. Let's see what that is. 74 divided by 27, 2.7 to 1. 2.7 to 1. I would estimate that's pretty close to 3 to 1, and that's what we're seeing. So it's kind of cool that you can see that number of nerds increasing so much. So that is a really quick introduction to how to do some of the math involved in this particular lab. Now, for the rest of the lab, what you're going to do, first you're going to graph your M&M data. You're going to have the number of half-lives, and you're going to look at the percent M showing. So grab that information. It will not be a straight line. Then there's a table that deals specifically with carbon-14. So we're going to look at the half-life of carbon-14, the number of years, and see how it decays. Then you graph that particular information on the bottom. Then you have a couple of post-lab questions. The first two questions use the graph you made for the C14. So you're going to look to see how many years or what percent is remaining, whatever the question is asking for, and you're going to predict the others. You use the graph. You're not going to do it mathematically, just give a best guess estimate based on that graph. The last three questions are general concept questions. So you should be able to look at those and figure it out. You might have to do some mental math, might have to get out a calculator, but no complicated equations on any of these questions. Good luck.